We have given f and g functions, and we have to find the compositions of f of g, g of f of f, and g of g functions. So, first, look at our f and g function. Because we have x plus 1 in denominator, and we know that denominator must be different than 0, so we see that for negative 1, this denominator will be 0. So the domain of f function will be all real numbers excluded negative 1. And in the second function, g function, we see that we have x in denominator. We cannot have 0 in denominator. It means that domain for g function will be all real numbers excluded 0. Now we can go to our composition. Function first, f and g, f of g, so f of x, this is equal. The first function f we just copy, and the second we have f of g of x. We can rewrite this. So we have to now replace g of x by the formula of this function. So we have f of 1 over x plus x. This is equal. And now we are going to our f function. The formula of our function is x plus 2 over x plus 1. So we just copy and we put parentheses for x. The 2 we just copy plus 1. And for x, we have to just put this whole expression. So we have 1 over x plus x. And in the denominator, we have 1 over x plus 1. So now, we can rewrite this. We have 1 over x plus 2 over 1 over x plus 1. This is equal. We can find the same denominator, so will be x. So we have 1 over x plus, in the denominator we have x, in numerator will be x squared. X squared divided by x is x, so we have the same what we have at the beginning, plus, denominator is x. In numerator we will have 2x. When we reduce x, we have only 2, the same what we have at the beginning. The same we have to do denominator. So we have 1 over x, we just copy, plus x squared over x plus x over x. This is equal. We have the same denominator, so we can put together this. Denominator will be x, and we just copy 1 plus x squared plus 2x over the same denominator. We have x, and we have 1 plus x squared plus x. We have division to fraction. When we divide two fraction, we just copy first fraction. So we have 1 plus x squared plus 2x over x. And we have to flip the second. So it will be times x over 1 plus x squared plus x. Now we have multiplication. We can reduce x and x. And we have, I can put x squared first, the highest power, plus 2x plus 1 over x squared plus x plus 1. Now we have to find the domain of f of g. So let's see first at the beginning. We have f of g of x. The domain of g of x was all real numbers excluded 0. So it means we have to exclude 0 from domain of our f of g function, And we have to check on this expression. This denominator will never be 0, so the domain of our f of g function will be all real numbers, and we have to exclude only 0. One more time, why? Because we have f of g composition. So we check the domain of g function. Is all real numbers excluded 0, and the domain of this function is all real numbers, because this denominator will never be 0. So we have to put together the domain of g function f and the domain of f of g function. So the domain of our composition will be all real numbers excluded 0. Next, we have to find the composition g of f. G of f. So this is equal g of f of x. So now we have to replace f of x by formula of our f of x function. So we have g of, and our f function is x plus 2 over x plus 1. So we have x plus 2 over x plus 1. This is equal. And now we are going to formula of g function. In g function we have 1 over x plus x. It means this x's we have to replace by x plus 2 over x plus 1. So it will be 1 over, we have x plus 2 over x plus 1 plus x plus 2 over x plus 1. This is equal. So because we have division, so I have to flip this expression. So it will be x plus 1 over x plus 2 plus x plus 2 over x plus 1. This is equal. To add this to expression, I have to have common denominator. Common denominator will be x plus 2 times x plus 1. So we have in denominator x plus 2 times x plus 1. And numerator, I have x plus 1 times x plus 1 plus, I just copy x plus 2 times, because we have in this denominator only x plus 1, so I have to multiply this numerator by x plus 2. So this is equal. Denominator we can just rewrite. So we have x plus 2 times x plus 1, and we have x plus 1 times x plus 1. So we can use formula for the square of sum. Let me write this here. I have a plus b to second power. This is equal a square plus 2ab plus b square. So we have x square plus 2x plus 1 plus, and in second expression we will get x square plus 4x plus 4. This is equal, and we can now combine like terms. So we will have 2x square, 2x plus 4x is 6x, 1 plus 4 is 5, over x plus 2 times x plus 1. We have our g of f composition, and now we have to find the domain. Like before, first we check the domain, because we have g of f of x. So we have to look at domain our f function. The domain was all real numbers excluded -1. So we have to exclude -1. And now we have to check for this function when this denominator will be 0. From this parenthesis will be for -2 and from this from -1. So the domain, when we put together domain f function, f, this expression, so D will be all real numbers excluded -2, -1. This is our domain. Now we have to find f of f composition. So this is equal f of x. So we have to replace f of x by formula of our function. So we have f of x plus 2 over x plus 1. This is equal. And we have, again, we have to replace x in our f function by whatever we have here in parentheses. So it will be x plus 2 over x plus 1 plus 2, and in the numerator we have x plus 2 over x plus 1 plus 1. This is equal. In numerator we have to add this expression and 2, so the common denominator will be x plus 1. We copy numerator x plus 2 plus, and 2 we have to multiply by x plus 1. The same will be in the numerator. We have x plus 2. In the numerator we have x plus 1. And to add this 1, we have to have the same numerator, so we have to multiply by x plus 1. 1 times x plus 1 is x plus 1. So this is equal. We have divisions, so we have to flip this denominator, and numerator we just copy, and we can do multiplication. So we will have x plus 2, we just copy, plus 2 times x is 2x, plus 2 times 1 is 2 over x plus 1 times, and like I said, we have to flip this expression. So in numerator we have x plus 1. In the denominator, we can combine like terms, will be x plus x is 2x, and 2 plus 1 is 3. This is equal. We combine like terms, will be 3x plus 4 over x plus 1 times x plus 1 over 2x plus 3. Because we have multiplication, we can reduce x plus 1, and we have 3x plus 4 over 2x plus 3. Now we have to check when this denominator will be 0. When x will be equal -3 over 2. How I get this number? We have to just solve equation 2x plus 3 is equal 0. So it means I have to exclude from domain of this f of f function -3 over 2. And we have to check what we have here. We have f of x. The domain of f of x was all real numbers excluded -1. So it means we have to exclude -1 and -3 over 2. So the domain of f composition will be all real numbers excluded negative 3 over 2 and negative 1. Now we have to find g of g composition. This is equal g of x. So now we have to first replace g of x by formula. G of x is 1 over x plus x. So we have g of 1 over x plus x. This is equal. And again, we have g of this whole expression. It means in formula of our g function, one more time, we have 1 over x plus x. This x's we have to replace by 1 over x plus x. So will be 1 over x plus x plus 1 over x plus x. Again, I just replace this x's by whatever I have here in this parenthesis. So this is equal. To add this two expression, I have to have the same denominator, so will be 1 over x will be, the common denominator will be 1, I have to just copy, will be plus x square, and the rest I just copy. We have 1 over x plus x. This is equal. We have division here, so I will change to multiplication 1 times, and I have to flip this expression, so will be x over 1 plus x square, and the rest we have 1 over x plus x. This is our g of g composition. And what else? We have to find the domain. Like before, we check what we have to find. We have g of g. So we have to check the domain of g function. The domain of g function was all real numbers excluded 0. And the domain of this function, we see this denominator will never be 0, so everything is okay, and this, when x will be 0, denominator will be 0. So the domain of our g of g function will be all real numbers excluded 0. This is my solution.